So let's cross-check the question again. The question says, calculate the heat change in 100 grams of ammonium nitrate 5 when it is dissolved in 200 centimeter cube of water. The temperature fell by 10 degrees Celsius. So specific heat capacity of the ammonium nitrate 5 is 1.4 times 10 raised to the power 3 joule per kilogram per Kelvin, and the specific heat capacity of water is 4.18 times 10 raised to the power 3 joules per kilogram per Kelvin, and the density of water is 1 gram per centimeter cube. Well, whenever you are solving a question, please try and then put down data. Data is very important and it makes the work more easier. So from the question, it says calculate the heat change. The heat change. So we are calculating the heat change in 100 grams of ammonium triazole. So let's see. The mass of ammonium triazole nitrate is given. So mass of NH4 NO3 and it's 100 grams of ammonium nitrate 5 when it is dissolved in 200 centimeters cube. So volume is measured in centimeters cube. So when it is dissolved in 200 centimeter cube of water, so the volume of water is 2000 centimeters cube of water, and the temperature fell by 10 degrees Celsius. So temperature is equal to 10 degrees Celsius. But from the specific heat capacity, the temperature is given as Kelvin. But let me remind you, in thermochemistry, whether in Kelvin or degrees Celsius, the values, we don't change it. So the 10 degrees Celsius is the same as 10 Kelvin. Yeah. So it's the same as 10 Kelvin. So let's try and then calculate the mass of water. The question says, okay, let's put the specific heat capacity down. So specific heat capacity of NH4 NO3 is 1.4 times 10 raised to the power 3 joules per kilogram per Kelvin, and that of water is 4.18 times 10 raised to the power 3 joules per kilogram per Kelvin, right? Okay, I hope you understand. So let's try and then find the mass of water, because from the formula or from the specific heat capacity there is no volume, so the volume of water must be changed. Whenever you see volume, you have to change the volume to grams. So from the question, density of water is equal to 1. So density of water is equal to 1. But you know, 1 gram per centimeter cube. You know, density is equal to mass over volume, right? So the mass, finding the mass of water is going to be density times the volume. So mass is equal to the density, that's 1 grams per centimeter cube, times the volume, that's 2000 centimeters cube. So the centimeters cube will cancel out, leaving 2000 grams. I hope you understand. So the question says calculate the heat change. Formula for finding heat change. Heat change is written as this. So we are calculating the heat change, but we have to find the heat change of the individual compounds given to us, as the ammonium and then the water, right? So let's try and find that of water first. So the heat change of water. By heat change, the formula for heat change is mass, mass times specific heat capacity times change in temperature. Our change in temperature is this, 10 Kelvin. So let me put water here so that you guys won't be confused. So the mass of water is 200 grams, but from the formula it's in kilograms, so we have to change this to kilograms. So changing this to kilograms, we will divide it by 1000, so it's 2 kilograms. So the mass here is 2 times this, that's 4.18 times 10 raised to the power 3 times the temperature, that's 10. So 2 times 4.18 times 10 raised to the power 3 times 10 give me 83600 joules, right? 83600 joules. Okay, so let's continue. Now we have to find that of the ammonium nitrate 5. So ammonium as NH4 NO3 is equal to the mass of it, the mass of ammonium nitrate, times the mass too must be changed to kilograms, so we will divide it by 1000, giving a 0.1 kilogram, right? So the mass times the specific heat capacity of ammonium trioxonitrate, 5 times the temperature, change in temperature, right? Like this, change in temperature. So we get something like 0.1 times the specific heat capacity of this is 1.4 times baby. So then times the 10. So 0.1 times 1.4 times 10 raised to the power 3. 0.1 times 1.4 times 10 raised to the power 3 times 10 to give me 1400. So 1400 joules. Okay, so let's find the change in temperature. So change in the temperature, total change. So this is the change in temperature of this water, and then change in temperature of ammonium nitrate. So total change or total heat change When we talk of total, meaning we are going to add it. So this R times N stands for reaction. So total reaction, change in reaction, is equal to 83600 plus 1400, giving me 85,000 joules. This is correct. Some of you can also change it to kilojoules. It's okay, it's acceptable. So changing it to kilojoules, you will just divide it by 1000. So dividing it by 1000, we get 85 kilojoules. And our answer is positive. It is positive because they said temperature fell by 10 degrees Celsius. When we say temperature fell, it means it is absorbed. And whenever temperature is absorbed, it's positive. And whenever it is given out, it is negative. So far as this temperature is fell, it means it is absorbed. It is absorbed, and it's positive answer. Thank you.